Exercise 251. 6 forces act on a beam that forms part of a building's frame. The vector sum of the forces is 0. The magnitudes Fb equals Fe, and this is equal to 20 kilonewtons. Fc equals 16 kilonewtons and Fd equals 9 kilonewtons. Determine the magnitudes of Fa and Fg. Okay, so first step. Write down the statements that the exercise is giving us. So, the summatory of forces is equal to 0. Second statement. Fb equals Fe, and both of them are equal to 20 kilonewtons. So, Fb, the magnitude, is equal to Fe, and this is equal to 20 kilonewtons. Fz equals 16 kilonewtons. And Fd equals 9 kilonewtons. The exercise is asking for the magnitudes of Fa and Fg. Second step, analyze the diagram. Okay, so as you can see right here, we have 4 and 6 forces, 6 vectors. 4 of them are not being applied along a specific axis, so we will have to determine some different components, and these 2 are being applied the y-axis. So the third step is to determine every single one of the components of the vectors that are not being applied on a specific axis. So in the case of Fa, we have Fa sine of 70 and Fa cosine of 70. In the case of Fc, we have Fc sine of 40 and Fc cosine of 40. In the case of Fd, we have Fd sine of 40 and Fd cosine of 40. Finally, in the case of Fg, we have Fg cosine of 50 and Fg sine of 50. I'm going to explain why did I use cosine or sine. In which case did I use either cosine or sine. And I'm going to do it just with Fg because the same thing goes for all the other 3 forces or vectors. Now, remember that this is a right triangle. And right here we have this 50 degrees angle. But when we're talking about a right triangle, you have to determine either the adjacent cathedus or the opposite cathedus. When we're talking about the cathedus that touches the angle, in this case this one, and we have to determine what are the magnitudes, or yeah, we have to determine the magnitude of that cathedus, we will use Pythagoras. Okay, and we will determine the cathedus by using its angle. Remember, the cosine of an angle within a right triangle is equal to the adjacent cathedus divided by the hypotenuse. Okay, so this is the adjacent cathedus, and right here we have the hypotenuse. which means that the adjacent cathedus is going to be the hypotenuse multiplied by the cosine of the angle. The same goes in the case of the y direction, which means the opposite cathedus of the right triangle. But when you want to determine the hypotenuse or the cosine, the sine of an angle, sine of an angle, we will use the opposite cathedus. So the sine of, in this case, 50 is equal to the opposite cathedus divided by the hypotenuse, which means that the opposite cathedus is equal to the sine of the angle multiplied by the hypotenuse, what we have right here. Now, as I just mentioned before, this information goes, or this analysis goes for all the other three vectors. Now, the exercise is asking for us to determine the magnitudes of FA and FG. How are we going to do that? By determining at least two equations. Okay, since we have two unknowns. Remember that when you want to solve a specific number of unknowns, you have to have at least the same number of equations. Okay? Since we have one and two unknowns, we have to determine two equations. Usually, those two equations are given by the summatory of forces within x and y, since we are talking about a 2D exercise. If we were talking about a 3D exercise, we have to use a z component. Now, summatory of forces along the x-axis is equal to 0. Why is it equal to 0? Because of this statement. Okay, I'm going to place this information, which I call first and last name. Why do I put that information here? Because for when someone else reads my math, he or she is going to be able to determine my point of reference. Okay, for me, everything along this direction, or that points the same direction, is going to be positive for x. Okay, and everything that points towards this direction is going to be positive for y. Okay, I could have said the other way around, that this is going to be positive. I don't really care about it. It depends on the author. Okay, since it depends on the author, I can say either this or this. The only requirement that I have to meet is that I have to keep the same point of reference along all the exercise. Okay, and that's it. Now, summatory of forces along the x-axis is equal to 0. What do we have along the x-axis? Minus FA cosine of 40 minus FC cosine of 40. I'm sorry, this is not equal to 40. This is a 7. Please bear with me. 70 plus FD cosine of 40 plus FG cosine of 50, and this is equal to 0. Notice that I've used the same colors right here. Now, we have one equation. We need the other one, which is given by the summatory of forces along the y-axis, first and last name. FA sine of 70 plus FC sine of 40 plus FD sine of 40 plus FG sine of 50. Notice that all four are pointing towards this direction, which means that I'm going to take positive. And finally, minus FB minus FE. This is equal to 0. Since I don't have any component, I can use the magnitude of the vector. Now, we have 1 and 2 equations and 1 and 2 unknowns. The exercise is solved. What I'm going to do is that I'm going to call, for example, this equation number 1 and this equation number 2, and I'm going to solve one of the unknowns within one of the equations. I don't really care about it. So, for example, I'm going to solve FA from equation 2. Okay, in this case, FA is going to be equal to minus FC sine 40 minus FD sine 40 plus, minus FG sine of 50 plus FB plus FE, and all this divided by sine of 70. Okay, if you are not following, what I just did was to place this right here. Remember that actually I'm not placing that on the other side with an opposite symbol, but I'm adding the same thing that I have right here using the opposite symbol. Okay, so I have to get an equivalence or a balance for the equation. And finally, I'm going to divide both sides of the equation by sine of 70. Okay, sine of 70. Now I'm going to call this equation number 3. And I have to replace this information within the equation that I've not used yet, in this case, equation number 1. So, minus FA minus, open parentheses, FA is all this, so copy, paste, close parentheses, multiplied by the cosine of 70, minus, and actually everything else. So I'm going to take this information, copy, paste, and that's it. This is going to be my equation. Well, no, I'm not going to call it that, my equation number 4, since I'm using equations number 3 and 1. So this is not a new equation. But what I do have right here is one equation and one unknown. So we will solve this equation for this unknown. By using its calculator, I'm going to write down the complete equation. So minus, open parentheses, minus FC. FC equals 16 kilonewtons, sine of 40. Minus FD, close parentheses, minus FD, which is 9, sine of 40, minus FG, which is the unknown. I'm going to call it X within the calculator, so X sine of 50 plus FB plus FE, which is plus 20 plus 20. All this divided by the sine of 70. Close parentheses, multiplied by the cosine of 70, minus FC, which is 16 cosine of 40, plus FD, which is 9 cosine of 40, plus FG, which is the unknown, x cosine of 50. And all this is equal to 0. Now I'm going to solve the equation, so I'm going to press Shift, solve, and yes, I want to solve the equation for x. Now, let me do a parenthesis right here. What the calculator is going to do is that it is going to create an iterative method in which it is going to try with a lot of different numbers until it finds the solution. The solution is given by when this equal is met. Okay, this requirement is met. Once the calculator locates or finds that number, it's going to it is going to show that number as the solution. The number that you can see right here is the first attempt of the calculator. The calculator is going to try solving, in this case, x first by this number, and then it is going to try with a lot of different numbers. This works because if I'm going to use a pretty difficult equation and I do know that the number or the solution is close to a specific number, which could be 100 minus 100, 200, whatever, I'm going to write down that number right here. Okay, which means that the calculator is going to find the solution faster since the number that I place right here is close to the solution. Okay, now I don't really care about it because our solution or our equation is simple enough for the calculator to not take a lot of time. So 200 equal, and right here we have the solution for x, which in our case is equal to FG. 15.2692 kilonewtons. Now we have the solution for Fg, which means that we can use this equation for us to solve Fa, since we have this unknown. Hence, Fa is equal to what I have right here is the same thing as I have right here, so I'm going to get rid of this and this, and I'm going to replace Fg with its solution. So Shift solve, yes, I want to solve it for x. This is Fg. I'm going to solve this within the calculator, so I just have to press answer, Shift storage, and I want to save it within, for example, the D space. For when I look for D, it shows the result. I do this because I want to use as many decimal places as possible. Okay, it is going to give me an accurate solution at the end. If I use the more significant digits after the comma I use, I'm going to get at the end accurate solution. So D I, okay, got it. So this is the part of this equation, this part of this equation, which is this same thing, this same equation, and I just have to replace this by D. Okay, and finally this is equal to 13 0.0184 kilonewtons. And that's it, guys. This is how you can solve this exercise.